Okay, this is number 35 on 2.2. We want to find the derivative at this point. So I found the derivative, kept the 4 out. The derivative of sine is cosine. You can think of theta like x. Its derivative is 1. If you were to replace the theta with what they give you, usually it's r theta, theta being 0. Cosine of 0 is 1. You're going to multiply before you subtract. So your derivative at that point should be 3. First thing you need to determine whether it's in terms of feet or meters. What I have written up here is the projectile motion formula. And 1/2 gt squared plus v sub o t plus x sub o. Now that 1/2 g is either going to be, if it's in feet, it's going to be a negative 16. If it's in meters, it would be a negative 4.9. But this is in feet. So I read the problem. The building is 1,362 feet tall. The object was dropped from the top of it. So if an object is dropped, its initial velocity would be, if you throw it upwards, its initial velocity is positive. Throw it downwards, initial velocity is negative. If you just drop it, its initial velocity is 0, right? And the top of a 1,362-foot building. So we have my position function. X of t equals negative 16t squared plus 1,362. That is called the position function. They also want us to find the derivative or the velocity function. If you take the derivative of velocity, the derivative of position is velocity. So you have, what's negative 16 times 2? Negative 32t to the 1 less power, and what's the derivative of a constant? 0. So you have your position and your velocity function. That should be what they want for part A. What is it? Anybody know here? So I'm trying to find the average velocity. Average velocity is a change in position over change in time. They want it from time 1 to time 2. Change in position would be x of 2 minus x of 1. So I put 2 in and I got 1298. Minus I put a 1 in and I got 1364. When you simplify this, what does this make the average velocity? It should be, is it negative 48? Yeah. And it would be feet per second because it is a velocity. Now I'm going to erase some of this over here is how I got the numbers, and I'm going to call this my answer for B. That's the average velocity on the interval from 1 to 2. Part C wants the instantaneous velocities at time 1 and time 2. Well, what's the velocity? Is it negative 32t? Is the velocity negative 32t? And I want the velocity at time 1. You put in a 1. Now we want the velocity at time 2. So I put in a 2. The velocity at time 2 is negative 64 feet per second. You may notice something about the instantaneous velocity. The average velocity has to be somewhere between the two instantaneous velocities. And that would be my answer for part C. Part C wants the instantaneous velocities at time 1 and the instantaneous velocities at time 2. For part D, they want to know when it hits the ground and with what velocity it hits the ground. So I might need my velocity formula too. Now the time it hits the ground is when its height above the ground is 0. When it hits the ground, its height above the ground is 0. If you add the 16t squared to the other side, you'd have 1362. You're going to take 1362, you're going to divide that by 16. And then to get rid of the square, you're going to take the square root, and you'll get it to equal about, and I believe it comes to about 9.226 seconds. That's how long it takes for the object to hit the ground. This problem used to, prior to when it happened, this problem used to refer to the World Trade Center. The World Trade Center is 1,362 feet tall. So whether you dropped a silver dollar or anything dropped from the top of the building would have been falling for 9.226 seconds, and it would have had an impact on the ground with a velocity of whatever we get when we put in 9.226. 9.226. Oops. So when you do when you plug in 9.226, you can find the velocity at that time. I hope that makes sense, that the velocity is negative because the object is traveling in a downward direction. And those should be the answers for D. Okay, 96 tells me a ball is thrown straight downward from the top of a 220-foot building. Because it's feet, I have to use negative 16 here. So I'm going to go ahead and just rewrite it. Negative 16t squared. And it's let's see what it happens. From the top of a 220-foot building, so I would imagine that's the initial height or position, with initial velocity of negative 22. So V sub O is the initial velocity, so I put negative 22. The question is, what is its velocity after 3 seconds, and what's its velocity after falling 108 feet? So, first let me write the position a little clearer. Negative 16t squared minus 22t plus 220. To go from the position to the velocity, you take the derivative. So the derivative of position is velocity. 2 times negative 16 is negative 32. This derivative would be negative 22. And the derivative of a constant is 0. So I think I now have my position and velocity functions. That's not the answer because they don't ask for that, but they're going to be used to answer the question. The question says, what's its velocity after 3 seconds? Well, I have the velocity function right here. Maybe I should just put in 3 seconds. So you get negative 96 minus 22. Does that make this the velocity at time 3 to be negative 108? I believe. And I think it's in feet per second. That would be the velocity at time 3. It also asks, what is the velocity after falling 108 feet?
Would it be 118?
Well, first, we're going to have to rewrite the velocity because it says what is the velocity when something happens, right? So I'm going to need my velocity formula. And it says what's the velocity after falling so many feet, right? So I'm going to rewrite this. X of t equals negative 16t squared minus 22t plus 220. Now, I'm going to do it like this. Negative 16t squared minus 22t plus 220. Okay? If it's at a height of 220, guys, and it's fallen 108, what's its height above the ground?
328.
Would it be 112? Do those add to 220? So I think the height above the ground, after falling 108 feet from a height of 220, I believe its height above the ground would be 112. So I'm going to subtract 112 from both sides. Lo and behold, I end up with this, and I think that becomes plus 108. Now I need to solve this, whether it factors or whether I use a quadratic formula, use my graphing utility to figure out where the graph hits the x-axis, in other words, find its zeros. That's what I need to do at this point. Use a quadratic formula. Again, you're going to find the solution to this using whatever method you like. That's algebra. I graphed it and I found that to be at 2. There's also a negative time, but that's before the event occurred. So that means I need the velocity at time 2. So the velocity at time 2 would be negative 64 minus 22, which is negative 86, I believe, feet per second. That would be the velocity of the object after it has fallen 108 feet. Again, after it's fallen 108 feet from an initial height of 220, its height above the ground is 112. I'm going to read 98. To estimate the height of a building, a stone is dropped from the top of a building into a pool of the water at ground level. The splash is seen 5.6 seconds after the stone is dropped. What is the height of the building? Now, if we read the instructions, it tells us it's in terms of meters. This right here will either be negative 16 if it's in terms of feet, like it was for 95 and 96, or if it's in terms of meters, it's going to be negative 4.9 plus v sub o t plus x sub o. Now, let's read what it says. A stone is dropped from the top of a building. That is, we don't know how tall, right? So, it's dropped. If you throw an object upward, its initial velocity is positive. If you throw an object downward, the initial velocity is negative. If you drop it, its initial velocity is 0. So, and I still have the initial height because I don't know the height of the building. Isn't that what we're trying to find? So I'm going to write my formula out. Now it says that it hits the ground after how many seconds? 98, 5.6 seconds. Okay, let me make a little room to fill in here. What I'm going to do is after 5.6 seconds, I'll put in 5.6 seconds, its height above the ground is what? 0, because it's hit the ground at that point. So I'm going to do this arithmetic and figure out what x sub o is. So I did the arithmetic, now I'm going to add it to the other side. And the book says the answer is 153.7 meters is the approximate height of the building. I hope these help. Good luck.